All right, we're back. We are MAPD124. That's Advanced iOS Programming, and in the winter 2017 semester at Centennial, and we are week 6, but we're doing lesson 5, part 2 of our broadcast. And we just finished talking about a couple things, C++, some of our document, the document itself on our hard drive, in our Finder. We did that too, to find the data where we keep everything, which is in this P list right now, which we're looking. And now we're going to start looking at some code. So again, use the PowerPoint for what it is. It's an excerpt from the book, right? But what we want to do is, there's different file saving strategies, and we talked about them already. I would say SQLite is probably one of the most common file saving strategies across devices. So if you're someone who uses Android, then SQLite is the way you want to go. And that's why I'm talking about it today. I'm talking about two, like plist and SQLite, not core data, because core data is Apple's way of doing things. And if you're going to do cross-platform development, so both iOS and Android, sometimes you can keep it exactly the same, right? You can kind of almost use the exact same SQL query statements and everything else, right? So that's why I'm talking about SQLite, if you're going to use SQLite at all. Again, we've talked last semester, you talked about Firebase. And again, I'm surprised that you did, but it's definitely the way to go these days. And if you were to look at why, because Firebase, I'm not going to go too much into Firebase because I'm not going to talk Firebase this semester with you. But if you looked at Firebase, and keep on changing stuff, major upgrades to Firebase. It's fantastic. If I go to Docs, you can see that they've got web, iOS, Android, all kinds of stuff. And notice that iOS is using Objective-C. Did you guys use Objective-C or Swift? Is there? Show me. Did I go to the wrong one? Log into Legacy. No. Where? Sierra New. I went there already. It's the same thing. Oh, Firebase.Google. Why didn't it take me there? Okay, anyways. So anyways, if you go to Docs, this is what I was looking for. I was surprised. Objective-C, I was like, here. This is what I was looking for here. So this is your stuff for iOS and Android and web. So Firebase, really popular, and we use it. Like I said, I was surprised. Web is definitely, I use Firebase with Angular all the time, right? So, and the Angular Fire, even with Angular Fire 2, it's the way to go. But surprised that they have the other one still up. Anyways, but you can see that they've got all kinds of stuff for iOS and even for Android. If you go through any of these things, there's some really good features and some tons and tons of tutorials. The API documentation here is by far the best I've seen, better than Mongo or anything like that if you're using some kind of mean stack or a full stack solution, right? So really cool. But we're not talking about Firebase this semester. We're talking about SQLite or core data or some kind of single file in a property list. Okay. I'm just gonna make this a little bigger so we can see it. I would normally go with full screen, but it always messes up my app, like I talked about before. It kind of crashes stuff. And I don't know what it is, why it does that. So again, what we want to try and do is originally create something called this root object. Now you can use either an array or a dictionary. For those people who don't know what a dictionary is, it's like a map. For some languages, they call it a map, right? What it is, it uses key value pairs to kind of store data, right? Which is in effect what we're doing with our P list. Our properties list stores key value pairs to store our data, and that's how it's stored. Bad things about using a single file is everything gets loaded into memory all at once, right? So if you have a lot of stuff to load, it takes a while to load. So sometimes it'll take time for your application to load if you have everything in a single file, like a P list with a lot of data. Bad idea, right? The good thing about it is it's like really easy to use, like totally easy compared to everything else, right? You can also use multiple files if you want. You don't have to use a single file, and I'll show you how to do that as well. I'll point to it, but more or less, this helps, but it becomes more complex. And if you're going to use multiple files, then you have to kind of balance between, well, what do I want to use now? If it's a very simple scenario, it can be okay. But if anything more complex than a couple of files, you're better off using SQLite, right? And that's the trade-off for me. For me, I always think about what's easier, what makes more sense, and what's scalable. From a scalability perspective, single file doesn't make any sense. But if I was going to do a simple game where I wanted to keep track of a high score, single file, it makes sense, right? If I was going to share my data with other people, iCloud, definitely I would use iCloud or the Game Center, or something like a Firebase, a MySQL server somewhere, something that I can share with other people. So it persists across multiple devices. All right, and again, we talked about these different ones. They talk about object archives in the book. The previous chapter to this one, I think this one is chapter 13. In the book is chapter 12. They show you how to use an object archive to do everything. Here, we're only talking about property lists, SQLite, and core data. And we're not going to talk about core data. So property lists. Again, we need to serialize our objects, and notice that these are the different classes. Remember we talked about NS in front of it means it comes from Objective-C, and that's what it is. An NS mutable dictionary or an NS data or NS mutable data or any of this stuff is all the stuff that comes from Objective-C. And we need to serialize it and convert it so we can use it with Swift. And if we don't do that, it becomes impossible for us to use. Now, they give examples of how to serialize stuff. So here's an example of an array, 1, 2, 3, right? And then here's my temporary directory path, NS temporary directory. When I see NS, it raises the back of the hairs in the back of my head. Now, I'm telling you, and that's how crazy it makes me. When I used to do old Objective-C, it used to drive me insane, right? NS URL, right? Temp file URL is temp directory URL dot append path component. And this is all the old way we used to do it, right? Now, then they mix it up with the new way to do it, which is our array.write to temp file URL, and then this thing called atomically true, right? Which is really weird. So if I actually look at my code, which is really what I think we should do, in the view controller, this is where all the code happens. Now, the author wrote this. That's why her name is still there. But I had to modify it to make it work, right? And that's why I put my name there. So here's where the funky stuff happens. So let file URL is self data file URL, right? So what does this do? Where is self data file URL? Where do you think this is kept? Do you see it anywhere? How do I add it in? Like how can I do this? Data file, let file as self data file URL. If I was to actually type that out, so let my file, my URL is equal self dot. If I start typing, notice what it says is an NS URL. Remember we talked about NS, next step, Objective-C. That's why you can use it. It's built in, right? And so you create a URL type an NS URL. And if you, unfortunately for Xcode, one thing I don't like about Xcode is you can't hover over and get like the types. I can't sit there and go, what to type? If I click over here though, you'll see it on the right side. That's their way of doing it. But notice how it has this little arrow like this. And remember the arrow, what it signifies is the data file URL returns. That's what it returns. The type is NS URL. And if I actually click on there and you go to see what this is, you can see that it gives you a nice description and how it says Swift. If I click on the Objective-C version, it's NS URL. It's exactly the same thing. And it talks about it being almost identical, right? The syntax for Objective-C is slightly different. Oh man, look what we're getting here. We're getting like these stars, which mean pointers, right? And we use this kind of bracket syntax, for to describe our path. We use the @ symbol here for Objective-C to denote that it is a raw string path. That's what it is, right? To not interpret that as something else and to avoid these backslashes or forward slashes as escape characters. Okay. So going back to Swift, if I go back to see what it looks like down here in Swift, it's exactly the same, right? There is no difference because it is Objective-C that we're using. And that's why it's kind of sucky, right? I got to be honest. And again, it was one of my personal issues when it comes to, like, I mean, it's not an issue for these guys. Apple is like, super rich, billion-dollar company. But myself, the way I look at it is, if you're going to make a language, and you're going to say Swift is the new language of Apple, then, I mean, they released it early to me, right? And they've been making changes a lot. And every change they make is a breaking change. It breaks every other change before it. Sometimes when I have developers like that, and by the way, I've worked with lots of people like that, lots of developers, lots of libraries, drives me crazy. I want to strangle the developers, right? Because, like, how many breaking changes are you going to make, man? On the other side, they did it because they wanted to. They're migrating slowly. If I was going to be, I'm going to take the other perspective for a second. I'm going to support Apple 1 second and say it's great because they're migrating. And for people that you are used to using Objective-C, this is a good segue, right, from one programming style to another, right? So if you knew Objective-C, then these classes and objects would be familiar to you because you've been using them forever, right? But we don't want these objects and classes. We want this in the next version of Swift. We want them to disappear, especially when it comes to data persistence. And if you do any kind of training, right, the training can tell you how to do user interfaces. The training can do all kinds of stuff. They leave data persistence to the end because of this ugliness with Swift. Okay, so here what we're doing is we're using the file manager object. And again, if I was going to look at the file manager object, and if I click onto it, look what it is, an S object, right? Which means it's an Objective-C, right? Construct, right? So this is the old way of doing things. If my file manager.default file exists at path file URL, right? Dot path. Again, they're trying to convert this, right? Then if it exists, then do the following. Let array be of type NS array, right? Or my file URL, you're casting it as a URL, which again is this URL type. And it's a string array that we're passing in. And for I, which we're creating a new for loop, between 0 and the array count, that's what it's going to be, however big the array is going to be. I want you to put in as many line fields as you can that are going to be attached to this array. Now notice line fields is our IB outlet, right? But it's not a regular IB outlet. What type is this? A collection, right? So we're using an IB collection, which is of type UI text field. So this is an array of text fields. So we can point multiple text fields to this outlet. Have you guys done that last semester? Okay. How do we do that? Let's go back to our main storyboard. Our main storyboard in this particular case has several text fields, 1, 2, 3, 4. And if you notice, from an event perspective, it points to an array collection called line fields. So does this one. So does this one. And so does this one, right? So what you do is you point to your view controller just like you normally do when you drag and drop. But instead of making this a single IB outlet, you're making it a collection, which means an array or a list. And you point to it. And once you've done that, line fields represents each of the text fields inside of your storyboard. So here's your storyboard. Each of these text fields this is text field 0, 1, 2, 3, and so on, right? So going back to this, how can you make this work for your note-taking or to-do app? It's very simple. You point all the same ones to the same outlet, and now you have a record of each one of those things, whatever you've typed in. We did it individually with a template row. That's also okay, right? But then you have to make it so that the template row points to a collection. So every time you add a new row in your template, it adds to that collection, another array, another element of that array, right? Once you have that, then we go back to our view controller. You can see that in here, we're creating this other array structure of type NS array, and it has to be of type NS array because we're using Objective-C structure, right, in our code. And you're converting the array, the collection, which is our line fields collection, right? you're taking the value of that array, so whatever the array count is, you're looking at that particular array, right? And you're storing whatever data was inside of that array inside of your line fields.text object, right? Where are you getting this array? The contents of your URL. That's where it's coming from, right? And you're storing it as a string array. So you're casting it, downcasting actually, as a string array. That's it. That's the line, right? So this is how you read it. So if my file manager, my default file exists, then good, read it. That's what this means, okay? This is this if statement. But what if it doesn't exist, right? What if it doesn't exist? Does it create it? Well, let's take a look, right? So here's let my data, whatever my data is equal to ns data. And again, it's the contents of my file URL as a URL. And then what we're going to do is, this is very interesting, we're reading with data as data. Oh, now there's another thing we have to talk about this one. What they've done is they split off this function into another logical controller, right? Here's this other function. So here you've got one piece, which is inside of your view did load. And there's another piece that's in here in your 4 lines of Swift, right? They call it 4 lines. But actually what you're doing is you're using an NS object, something called, and by the way, NS coding is a protocol, right? As well as NS copying, which is another protocol. So you got 2 protocols in there, right? And here's your copy function and your encoding function, right? And what you do here is these 4 lines, they have these different methods that we can access to copy data from and to. And we want to encode the data and put it back into the proper format so it's compatible with our plist, right? Our XML. Okay? I'm not going to go into details here. Would it be okay for you guys to use this code? Absolutely. Please use this as a template if you're going to use a plist. Okay? I don't expect you to rewrite this code and make it, your own. I do expect you, though, however, to adapt it for use for yourself, right? So if you go back to Swift, our view controller, right? Here's 4 lines of code, right? There's 4 lines here. You're making a reference, right, to this decoded object as something that is related to this 4 lines object that you're creating, right? So you're decoding the object, whatever, depending on what the key of the object is, in our view controller root key. I scroll up. Root key is this basically API key that you're using, a secret that you're using to store your data. That's what it is, and you're decoding it here. Here's the secret, and here's what you're doing is you're actually applying the secret here to get it back. For those people who don't know what I'm talking about, basically you're serializing and deserializing, right? So you're serializing when you're storing, and you're deserializing when you're reading. So you're coding and decoding. Coding when you're reading, or you're writing, I mean, and decoding when you're reading it back in. Okay, that's what's happening. All right, so now, new lines is what you're doing is your 4 lines. Now this is the way they did it. And what you're doing here is you're reading in each of the new lines into your text field. Now it seems that you're doing it twice. Both of them are arrays. Here's an array, and here's an array. And both of them are doing the same thing. Okay? Here, you're doing it and you're reading data. But when are you ever writing data? Right? Well, okay. Now, I'm going to go through this in a second. But if you look at if you didn't even know what was happening here, if you're just looking at this thing, notice that says selector is selector and self.application will resign active notification. Does anyone remember what application will resign active? What does that mean? Remember we did that one time when we did our when we clicked away from our app. Remember we did that? We actually will resign. We actually resigned our kind of our delegate, right? Our application delegate. We used that so when we clicked away from our keyboard, then the keyboard would go down, right? And we kind of resigned control of the keyboard. Well, this is kind of the same thing, and we're calling it from in here. So here we're defining things like, again, our file URL is a data file URL, here's 4 lines, which is a, remember we do this in Swift, we don't have to use a new keyword to declare an object of type 4 lines, right? And we're doing it locally here inside this application mobile design active, right? So here we're saying our array is self.line fields as NS array, and we're taking the value of the array itself and casting it as a string. So this is where it takes everything, and our 4 lines, little object, it takes this information and copies it in. All right? Cool. Now that we've done that, we encode everything and write to the file URL. So this is where the writing is being done, right? So again, we do our writing in this method right here, and we do our reading in this method up here, these methods up here, right, inside of viewDidLoad. Now we do have a data file URL object that returns NSURL, and that's what we were using this whole time. And what this does is it basically creates a file path, right? Here's create a blank path, right? And what we want to do is we want to write to data.plist, and data.plist is the property list where this is being written to. Going back to our situation, notice it says data.plist, not info.plist. Data.plist is actually on the actual device itself. So this is where it's being written. High level overview. If you're confused, don't worry about it, right? I'm trying to give you where everything is right now before I explain how everything does what it does, right? Because you need to understand how she structured this thing. By the way, is this the only way it can be done? No, this is not the only way it can be done. This is the way the author wrote it in the book. And if you have the book or have access to it, the code is very similar here, right? It's not the same as the book, though, because I had to make it work, right? It wouldn't work the way she had it written. So if you find differences, and the main differences are when she's coding and encoding, right? Then it's okay. It's because I had to go in there and fix everything so it worked. And it's usually, I think it was this one right here. This line was the culprit. Or it could have been this line. But it was in here that where the problem was. Okay, so again, 2 parts. So this all happens on viewDidLoad. So when viewDidLoad triggers, this is when the view comes up, it reads automatically from the properties, is the plist, right? And what it's going to read is whatever this file URL is. And the file URL that it's going to get is from this data file URL, which is right down here, right? It's going to look at this data plist. This is the URL. And then if it can read it, it's going to say, great. Otherwise, it's going to produce an error, right? That's what it does. And it casts it. It casts it as an NS URL because it needs to cast it in order for us to consume it with Objective-C code. And this is why any kind of data persistence at the even easiest level is really challenging to kind of dissect, right? Because you have to mix both our old stuff, Objective-C, with Swift. Okay. Let's go back up here and take a look at this again. The logic behind this. So here's our if statement, right? So this only works if the file exists, okay? If the file exists. So here, file URL equals self.data file URL. What this does is it says we're making a reference, right, to this data file URL, but we're also calling it at the same time, right? And when I call this data file URL, right, once I call it, you know, as an example, does it return anything? No, there's no return for this thing, right? But it sets up the file URL itself. By the way, notice how it calls itself right here. Here's the data file URL. So here we're saying file manager again, default URLs for this, and this is broken up over 2 lines so you can see it doesn't have to be written this way. The document directory, which is on the actual phone itself. There's a document directory, just like we see here. Guys, sorry, I have to compete with you. I love you guys, but I can't. I'm too old. I'm an old guy. It's hard for me to speak louder and louder. But I do love you guys. Happy Valentine's. All right. And if you look at over here in documents, See how this works? Where you have data, application, documents. Again, inside of our documents directory is where this property list is being stored. This would be equivalent to what it would look like on the phone. It's not on the phone. It's in my simulator. But this is what it would look like, right? Document directory. All right. User domain mask is, in the user domain, and that's depending on this. This is a requirement. By the way, there's other options here. If I was to take this out, and if I press dot, you're going to see that there's a bunch of other options, right? The system domain mask, the network domain mask, if you were making it something that was across a different network, and so on. Again, I have to get you to remember that this is a Cocoa Touch class, right? Going back to Objective-C, and this is why we're saying user domain mask, because it means it's only for one user, for the person that's logged into this phone, right? Here's our NSURL, right? Again, our variable URL is of type NSURL. That's what it is. And notice it's an optional. We can still use this in Swift, right? And we're saying is, and they wrote this in 2 lines, our URL, we create a new URL object and file URL. We're in our constructor, right? We're setting the default file URL with path parameter to this empty parameter, this empty path. And again, we're casting it as an NSURL. We're doing it twice, right? Now you might say, why are you doing this over and over again? Because that's what Swift needs from a syntax perspective. If you don't give Swift this, it won't work. Then we do a do catch, which is like a try catch in other languages. This is our error handling, if you will, right? Or exception handling is a better way to say it. And this could throw an exception if, when we want to append path to component data plist, doesn't allow us for whatever reason. If maybe we don't have access, maybe there's already a file that's there that's already there it can't write to, or whatever, some kind of weird error. It's going to throw an error, and we're going to say some kind of error. Error is whatever the error is that's going to prevent this. And we're using this interpolation to show the error on the console. All right. And then when we're done, notice because we have this return, this returns an NSURL, right, which is going to be the URL. And think about the URL as the path on your device where this thing is, with the name of data plist. So that's what this data file URL does. It basically sets up this situation, right? So here, once we call it, file URL now is stored. It stores a reference to this data file URL that we just created. Okay, and now we can use it. File URL path. If it exists, great. Read from it if there's anything to read, right? Here's where some funky stuff happens. UI application shared. Okay, UI application shared. When I do this, and if I hover over what UI application shared is for a second, notice that this is Swift. Thank God, right? Back to Swift again, right? So our app is this UI application shared object. That's what it is. And then what we're doing is we're using Notification Center, right? And we're making an observer to say something like this. Hey, if there's nothing here, right? If I don't have anything inside of our path, and this is really funky to figure this out, right? When you look at this. But if I don't have anything in here, then call UI application will resign active. That's what we're going to do. Where we're sending off this notification, right? There's your application will resign active. Remember, does all of our writing. This is where our writing happens. And we're sending a message. This is where it's really weird, right? We're sending a message from our view did load, right? When necessary, especially when it's empty, or if we add something new in there, to our application will resign active. And this creates another path the same way, another reference to the path. By the way, does it create another one? Yeah, it does, because look, this is local to this, and this, right, is local here. Question is this: will it ever get here if this is true? So if file manager default file exists, it does all this stuff, reads from it, right? If not, it skips it and goes right here. Oop. right? That's what it does. Skips it. It's almost like an else statement without an else. There's no need for an else. It just does it right here. And what it does is it calls notification default observer, right? And what this does is from here, it hits you into resign active, application will resign active, which actually does the reading of the data, right? If it's required. That's the way it works. It looks ugly, but it just works, right? And what I want you to do today is try and incorporate this into your code, right? So if you have your application, think about, how can I use this? How can I write my plist? You need this for sure, data file URL. So you need to put this in, or something like it, in your code, right? Definitely. Where you might have a problem is the idea that they use something called 4 lines, which requires this code. But this is okay to use, because 4 lines, all it is the way for us to encode and decode our information to and from the plist, right? So this is okay for you to use, okay? So I would include 4lines.swift inside your code. That's what I would do for sure. It's already been pre-written for you. And then pretty much you have the code. You just need to adapt it to work for you. Notice that this part here is the part that you want to put into your view did load, right? And this part, you'd have to convert all your IB outlets to using a single collection, right? But you remember, each IB outlet is actually using some kind of row, because you're having these template rows. Remember from last week, right? Or 2 weeks ago? I know it's hard to remember 2 weeks ago. It's like another lifetime, right? But that's what we want to do. We want to kind of be able to use our IB outlet to do that. We can do it together, but then we wouldn't. If I did it with you together, I'm just being honest and telling you, we're sitting at 8:54 right now. I wouldn't be able to do any kind of SQLite with you. It would take the remainder of the class. Just FYI, right? So my recommendation is today, you try and do some of this by yourself. Now, if you're working with other people, I will allow you to work with others to do this for your code, because this is something you need to work and make work with other people. Remember, for the exam next week, the reason why I'm not making this part of the exam is try and code this on your own and figure it out. It take you all week, not 4 hours, week to get this done properly. Go and research on Stack Overflow and everything else to get it working. Particularly for your application, it might take you a while if you've never done it before. It took me a while. Like I said, it took me 8 hours to figure out the problem, make it work, install it, test it, whatever else, right? And to try and explain it to you guys, right? And I'm not just talking about this one, each of them. I did all of them, right? All the different ones. Okay. Sounds like a lot, but really, when it comes to research and trying to figure out what happens, this is what it's all about. Is it that difficult to figure this out? Not really. The reason why we can use lets with objects like this is because we're not actually physically changing the object. We're changing its properties, which is totally allowable, right? It's like using a constant. This object is a pointer to NS data. So I can use the let keyword instead of var, right? And it's safer because what it does is it locks it down. That's what it does, right? I notice it uses lets for everything. It's almost like saying const. Everything is a constant, right? Because he doesn't want you to change what this thing is pointing to. I can't reassign this data object to point to something else other than to this NS mutable data, right? And again, NS mutable data, if you look at what it is, if I click onto it, it's a type NS data, Objective-C, right? And it's like a dirty word, Objective-C, right? But that's what this does. NS mutable data allows us to hold data that's compatible with Objective-C, and we're going to use this same object not only to write to, but to write to this file URL. Now, atomically, what does this mean? And if you actually look at what this write does, right? Notice that func write, what it does is it says writes the bytes in the receiver to the location specified by a URL. That's what it does, right? Now, write to file atomically, there is no difference between this method and write to file atomically, except for the type of the first argument, right? Which is this, which is of type URL. So I could just do it, whether it's Boolean true or false, right? Now they're saying it's true, and you can see why it's true if you read the documentation. Returns true if the operation succeeds, otherwise returns false. Right, so that's one thing it will do. It will return a value if the write was unsuccessful. So theoretically, we could, if we want to, wrap this in a do catch, right? But we're already doing that here, right? So there's no point doing that. If this fails, then this will fail. And chances are if this doesn't fail, this won't. But anytime you do reading and writing, theoretically, I'm just putting it out there from a best practices perspective, you may want to do a do catch, like up here. Instead of this if the file exists, right? The other way to do this would be to do a do catch and surround this thing with a do catch. Because then it would pump out an error, say that no file exists, or there's an error. Clear as mud? I'm pretty sure it's hard, right? The PowerPoint as a reference. I'm going to go back to this for a second. If you step through each of these things, it talks about how each of the Cocoa Touch classes, NSURL and UI image and UI color, and all these kind of things, how it uses the Objective-C properties to make this happen. Okay? Just putting it out there. And it gives you some exact ideas of everything I just talked about. It actually, if you step it through, it actually steps you through how to create this app, right? So in Xcode, it tells you what to do. You call it persistence. And notice that we create this, we single click the view controller Swift and add the following outlet by itself. So we add the outlet first. This is different than what we normally do. And then we drag and drop our lines right to it. So if you're going to use something like a template row, that template row that you're using, you would first create the IB outlet and point to it with all the rows. That's what you would do. But you'd only have one because the template row would point to one. But every time you go there, it would add into the rows with this. Another thing to really take a look at for me, whenever I look at this kind of stuff, is I always look at the stuff that they've given us. I'm just going to shut this down for a second. So I'm going to close this one off. And if I was to do a sample application with Xcode, so if I go to make a new project with Xcode, and if I was going to create one, which is this master detail application, which is kind of what you're doing, right? Next, and I'm going to do another master detail because I've tons in there as samples, right? Again, you can always choose to use for the dreaded Objective-C, but don't use it. Notice that you can actually use core data if you want or whatever. For now, we're not. If I click next, and I'll save it there. One thing to note is that the master detail application, right, has several view controllers, right? So you've got your master view controller, which is the main one. And the thing to note is how they do it differently, right? And I always like to look at code that's been written by Apple, right? Because this is stuff that's been written by Apple, right? And how they do things. So here we insert new object. Notice that they use NSDate, right? Objective-C, NS, next step, right? Whenever you see that, it's Objective-C, right? And how they insert things, they insert rows, how they do that kind of stuff. Now it says self.tableview insert rows, and what they're doing is this is what you do. If you actually press the plus button, you would insert rows in here too. And notice how they're using a prepare, right? This is a prepare for segue, so that when they do that, they collect the data in the rows, right, of type NSDate. And again, we want to store the date. When I run this thing, that's what it stores. If I run it for the first time, no, not an iPhone 7. iPhone 7 is going to go away. It's going to be iPhone 8 in a couple of months, right? It will be, right? They're going to come up with a new thing, whatever. It's going to be their June conference where they're going to come up with the iPhone 8, right? We know it's coming, right? Yeah, of course. And it's going to be the latest thing. So people, you bought an iPhone 7 for nothing, right? I'm joking. iPhone 7 is pretty cool too, but better off waiting. So if you click the plus button, the way this works is it captures the date. That's what it does, right? And if I click on it, it gives me the detail view for the date. That's what this whole thing does. That's the master detail application, right? And it tells you right here what it does. Here's the object where it says objects index path.row as an NS date. That's what it does. And as you make that segue, after I click on this thing, it's going to take me to the detail controller, right? So notice that it also, the one thing they do is they also annotate it pretty good. There's not a lot of comments. I know people are, there's two camps. No comments. Don't put comments in the code. It's terrible, right? Because too many comments are like looking at an app delegate, right? You got, in this case, you got lots of comments and one line of code, right? And people hate that. A lot of developers hate this idea of looking at a piece of code and reading a bunch of stuff about one line, right? Where you could write this in API documentation, right? And then there's the other camp that says, like me, that says, write comments when it's necessary. Tell me what this stuff does, right? If it's not immediately viewable, if I don't know what this thing does. Like, for example, this table view, right? So function table view, it says override. So what I'm doing is I'm overriding stuff that already exists in my view controller, right? And what I'm returning is an object's count. But look, there's 1, 2, 3, 4, and all these different ones are overloads of the table view. That's what I'm doing. They're the exact same method, right, written over and over again with different sets of parameters, depending on the situation. Okay? So there's this table view idea. And here are my segues. And the rest is the stuff that happens in my view detail. But notice there's no IB outlet. You see an IB outlet anywhere? How did this connect? So if I go back to my main storyboard for a second, let's go over to here's my detail view. And on the left, I've got my navigation controller. Detail. Oh, there we go. There's my data, my prototype cell. This is what you guys are going to do, right? And if I look at this, it says, okay, my selection goes to my navigation controller, show detail. So when I close on this thing, right, I've got 2. So data source master, delegate master, which is my master detail. Okay. So those are the 2 events that happen. If I click away, I click into the cell, it shows me that my selection goes to my navigation controller, show detail. Okay. So if I look at my navigation controller, I click onto it, you can see that this is the way it creates the relationships between the segues and everything else. But how does it write everything to my detail view? How does it go there? Well, when you click on the actual object itself, which is the prototype cell, then this generates the segue. That's what ends up happening with it. It generates segue from here to the master detail view. How does this match? How does this take the information out of here, from my prototype cell, right? And by the way, if I look at this thing, here's my prototype cells, which says 1. If I click another one, I can add as many prototype cells as I want, right? Right now, it only says 1, and it says dynamic prototypes, right? As opposed to static cells, okay? But where do we have that information? Where do we have the information of what this prototype was doing? Remember how we linked into it last time? Where does it show us, what this thing is called? Well, there it is. Cell identifier is called cell, right? It's like we did. That's kind of a very common way of doing things, our cell. And then we link into it through that. Let me look at that in code. Here's our master detail view, right? Where's the cell? So is it here for our cell itself, right? Here's a show detail. Well, here's a table view. And this is an overloaded method of our table view, which is basically we're using the cell for row at, like we did last time, where we let the cell is equal to the table DQ reusable cell that is called cell. And this is what we want to do here, right? Now, look at the object and a state. This is a great example of the stuff that we want to do, right? right? Where we kind of take the objects at data row and we cast it as a date, right? We want to do the same thing when we encode it and put it inside of our URL path that we had from the other application. So this gives us a hint of what to do. Questions about this? Why am I bringing this up? Because this looks exactly like how we have it right now in our prototype. Let me show you what I'm talking about for those people. And now for those people who said, "Hey, Tom, you didn't put up your stuff up on GitHub." I'll do it now when I bring it up, right? So I'm going to file open, and that's not a great thing to do. But we can look at the MAPD124. We did for C. I think that's the one we did. This is the last one we did because this is officially lesson 5. That is really weird. And that's it, actually. Sorry. Oh, this was I actually did another one. This is what it was. It was 4C, where it was the master view detail page. Sorry. So I actually had that already. I'm going to open, and we're going to go to 4B. See if that's the one. Yes. We did first view and second view where I kind of talked about the controller. That's not it. Hold on. Close this one. So it's 4A. Well, you got to get it right one time, right? If it's not one, it's the other. Here it is. Okay. So in our master detail view, this is our prototype cell, right? And if I go to my view controller, right, this is all the stuff we did last time, where their table view and our cell with the identifier as rows, not cells. They use cell, we use rows. Doesn't matter, right? Okay, so what we're saying is this. We're saying cell label text is equal to data index path row, whatever that is, right? And we're storing the data inside of our text. That's what we're doing, right? And we're returning the cell out. Okay. Inside here, do you see an IB outlet or some kind of way of connecting the cells? There's got to be some way of connecting everything up, right? And yes, we have an IB action, a couple of IB actions here. And then inside of our custom table view cell, we have a bunch of weak IB outlets for this stuff, right? Okay. So remember what they did. They used a collection, right? And they used a collection of one type because all they were storing was one piece of data, right? We're storing 3 pieces of data, right? Our label, the button, and the switch. Those 3 things that we're storing. You don't have to make it this way. You could also do this, the other things. But if you're only storing one piece of data, then you can use, instead of each of these being an outlet, you could use something totally different. You can use an IB collection, an IB outlet collection, right, to store all of them. But however, we have a problem, right? If we use a collection here, the collection has to be of only one type. And there's 3 different types here: UI label, UI button, UI switch. So what do? There's 2 options. You could create a custom class that holds the actual cell itself. And we have it. It's called custom table view cell, right? That's what it is. And this custom table view cell, the data from it is the stuff that we're using. Let's go back. So view controller, custom data view cell is the one that we're making use of, right? So where is it? It's right here. Cell is an object of type custom table view cell. That's what this is. And this is how we're able to get to the text and the tag and all the stuff that's inside the cell itself. And we also talked about how we did it down here, where we had our cell and how we can update the cell with the sender tag and all that stuff. Okay. So that's one way of doing it. What's the other way? Is there any other ideas? Do you guys have any other ideas of passing data? if you're a developer of any kind, then you've made classes to pass data before, right? The other thing to do is make a container class, right? Instead of using the data that's inside the object itself, we use it as temporary storage, right? And we create a container class that's separate over here somewhere, right, to store our data. And then we make an array of that type of container class, right? And that array is the one that we're going to be sending to the plist, right? That's the other way of doing it. Brute force. Remember, we talked about best cases. Let's talk about worst cases, but it'll still work, right? If you look at our custom table view cell, right, it has 3 of these weak kind of IB outlets. What you could do in here instead, right, is you can make these each an array of cells, cell labels, an array of edit buttons, an array of cell switches. You can try that too, right? That might be the brute force way of doing it. The only challenge I have with this is that each of the prototype cells in this particular case are going to be objects that are generated dynamically, right? They're not going to be something that is generated statically. Now, did we ever say how many cells we're going to make? Did we ever say that? Like, take a look. If I was to run this application the old way, right? Do we have a fixed number of cells right now? One day when it loads. iPhone 6 again. My iPhone 6. We have 3 of them right now. Test 1, test 2, and test 3 with a couple of these switches, right? We did this last day. Hey, now that I'm here, let's remember to put this up on GitHub, right? For those people who need it. So if I click edit, it takes me to my other page, and you can see if I click this on the way back, no effect. But if I click this here and go to edit, it retains that data from one view to the next, right? That's what we ended up accomplishing last week, or the week before we were away. Okay, that's what it did. That's where we're at right now. But how come 3, right? Do you remember how we did that? Let's go back to my view controller. Well, yeah, here it is, right? Test 1, test 2, test 3. And we're getting the data from this data, static data. That's not what we want. We want to read the data by using our plist, right? So we can set up a structure that does this, test 1, test 2, test 3. And once we've done that, we've set up how many rows we need, right? The rows are going to conform to how many we need based on what's inside of this data array. This data array is going to come from the plist that we're going to read, right? Based on how big that is. So again, this is the kind of stuff that we want to be able to do. We wouldn't do it here. We would define an object of data of type string, but we wouldn't do any kind of initialization, right? Now that it's at the class level, we could go into our view did load and assign the data right at the top, just like we normally would do. Okay, so that's kind of a hint of what we can do. And then the rest is very similar. Because notice that this view did load, all we have in here is just these lines right here. That's our view did load. And what are we doing here? We're saying our current task is whatever the task is, right? And where do we get tasks from? Our task list. This is it. We've made it already. Here's our container class from last time. So what do we need? An array of tasks, right? Array of tasks. This stuff is going to be stored directly to the, to the properties. I've already prepared it for you from last time, right? Okay, let's go back. So when we say current task is equal to, we're creating a new object of type task, right? That's what we're doing here. And the name is empty task, the completed is false, and the note is currently empty, right? That's what we're doing here. That's what current task is. Current task is a class variable that's right here. So this is part of the view controller class. And what we're going to do is every time Remember, because the table view is going to generate itself, right? Based on how many of these of the data cells we need, right? So here we have our cell for row at, right? And this is where we generate each of the rows. But where, oh, where do we tell it how many rows to generate? Or here's our prepare. This is when we move from one place to the other. Here's our cell edit button touched. And these two IB actions do things for our cells. But how do I know, sorry about that. How do I know how many rows to generate? Where does it tell me that? Do you remember how to do that? Yeah, it's right here, right? So return data.count. So this tells me how many data rows I'm gonna take because of this, right? But this is going to be dynamic. This is going to be coming from our P list. So that's a hint of how we can kind of combine these two to make them to go together, right? So again, it's like, and if I was going to pull up the other thing for a second, if I was going to open up something that we did recently, which is this. All right, and we can look at these side by side. We need some dependencies. We need this 4-line Swift. We need this one because we're going to need that to make this whole thing work, right? If we're going to just adapt this whole class. And this part here, instead of reviewed load, all this stuff has to happen, right? Has to happen before we get down here, right? Where our app gets written to, okay? And notice that somewhere in here where there's data, right? We're going to use this data, which is of type NS data, to basically talk about this. It's not going to be a string of data anymore, test 1, test 2, test 3. It wouldn't be that anymore. It'd be of type NS data. So that's going to be a change. We're going to have to change up our code a little bit, right? But what it's going to do, it's going to give us this count, whatever that count is, right? And do we ever use that data string again anywhere? If I was actually going to search for data. So I go data, right? There's 1. There's 2. Sender.tag, right? Because we do that when we go to the next place there. Our data, whatever the sender is, whatever we click, that's what this is, whichever one we click, right? Is we're going to be using that to say whatever the current test name is whatever the tag name is of the object, right? So that's the 3 places we use it, here, here, and here. And notice that here is index path.row because we're making it use of its, remember, because we're saying data is a string, okay? And that's going to be our index. We're still going to pass in an index. When I go back to the other one, data is of type NS data, right? So this won't work. We can't use the same name. We have a conflict, right? There's a different data, right? We're going to have to figure out how we get these lines. And a lot of times we notice that new lines or line fields is what we mean by data, which is of type UI text field, right? Instead of it being strings, we're going to make it of, we're going to have to do something like this, okay? That's how it makes this work. Ours is slightly different, right? So we have to adapt what we have here to there. And that's going to take the, like I said, if we did this, would be the remainder of the class. Or I can show you, and I mean, we're talking, we're 9:21 right now. We'd have at least an hour of work to get this done. So it's up to you guys what you want me to do. You want me to adapt this? It's one thing we can do. Or do you want me to talk about SQLite, which is another option, right? Hands? I guess, do you guys care about that? Right? SQLite. Okay. I'll leave this for you guys to do then. SQLite. I like that. Thank you. But it would take us time to adapt to it. It's not impossible. Like, it's already there. For this one here, which is lesson 4A, I'm going to go to source control and I'm going to do a new commit. And what we did last time was we added our detail view. Added detail view. We're going to commit those 2 files, and then we're going to go to source control and push. We could have done it right there too, but why not? So now you have everything on GitHub for those people who care. All right, SQLite. SQLite is a totally different monster altogether. Now again, like I said, if you step through all these PowerPoint slides, they basically build up the app that looks like this for you. So this is some good reference on how to build it up, and it talks about what it looks for and everything else. So it's a good exercise for you to do this. SQLite, from slide 45 on, or page 45 if you're using the PDF. All right. So this is where one of the things that there's an advantage of SQLite is it's a table structure, which matches what we want to do a little bit better than using some kind of file, right? Using a single file is great for a single piece of data, like we talked about. But see the difficulties? We're trying to think about, oh my God, how do we map out our cells? Do I create a class? We made a container class. We could do that, and each of the cells could be, could be used. But it's almost like we're trying to map a complex structure to more of a simple structure, single pieces of data, right? That we want to store. Here, this is a little bit more robust, but by no means easier to use. It's not easier, right? Again, this talks about how SQLite is structured and how it is an object relational mapper, right? Different techniques, right, that we use. One of them, the one that they use for Apple, is core data. We don't use an object relational mapper with SQLite. It's just strict direct access. Sorry, that's what I meant. Now, one of the things it does is before it says you can use it, you must open the database. And the way to do that is to use SQLite open. This structure is an Objective-C structure. Notice that we have a different kind of structure over here. And we need to create something called an opaque pointer. Opaque pointer, right? And no, when you look at it, you're like, what the hell is an opaque pointer? It's just their way of, an opaque pointer is a way of, and it explains later on, of connecting the C language to SQLite, right? Because SQLite was originally the using Objective-C, and now we're trying to make it, make use of Swift, and so we need to structure things with an opaque pointer. Now let's take a look at the code as we go, because it's important to do that. We don't have a lot of time left. And what I want to do is I want to pull up our SQLite persistence, right? Again, this is I put it up on GitHub already, so you guys have all this code, right? All right, so let's take a look and see if we can dissect this. var, my database, is an opaque pointer. That's what it is, a pointer type. We're setting it up as nil, which is like no or nothing. We're initializing it, right? This is inside of our viewDidLoad. Our result is equal to our SQLite 3 open. We're opening a data file path, okay? Where's our data file? Notice that, by the way, this is exactly the same. We still are using our multiple line fields, right, for this, that are pointing to this IB outlet. So this is an IB outlet collection, again, a collection of outlets, which creates an array of UI text fields. In your case, you'd be a cell, that cell array, right? Okay, again, so what we're doing here is, if the result is SQLite okay, like this is like saying you're getting a good response from your SQL server. Remember, the SQL server is running locally inside the machine on your application. By the way, does this look familiar? Or if you look at this on Android, does this look very similar to Android? Somewhat, right? Somewhat different though, because Android is totally easier, right, than this. Android is like close your left eye and you got SQLite, right? But here is like it's not quite as simple as that. So if we're okay, great. We're going to close the database. If it's not okay, then close the database and say failed to open the database, right? If it's not okay. Else, if you get by this part, line 24, that means everything is okay. And that's when you're going to do this. You're going to create this SQL table, create table if not exists fields, right? And then plus row integer primary key field data text. All right? So row integer primary key, right? And then field data is text. Okay. So field data is the actual name, and text is the type. Row is the name, what it's a type of integer, and it's the primary key. I don't know why they would call it row. You could have called it ID. You could have called it anything. Why did they call it this? Want to strangle somebody again, right? But this is how it works. So basically, create table if it does not exist. If it does exist, you know, then we can avoid this thing. This only if it does not exist. You do this line. Create SQL. Error message. Oh boy. Unsafe mutable pointer. Right? We need to do this to make it nil because we need to make this error message compatible with Objective-C. Okay, now we're executing this statement, right? Result. No, result here. Result. Execute. Connect to the database. Take this create SQL statement with a couple of other modifiers and pass a reference to the error message, which is right here, a pointer to the error message. And again, if result is not okay, notice that this has been duplicated, right? Then close the database, and we're going to return fail to create table. Guys, to me, this is why I went with C++ in the first place. Way easier to do myself when I look at this stuff. It speaks to me, right? Up until now, okay? Just saying, right? Query. Here's our query. Select row, right? Select row would be ID, right? Field data and field data. So both the row and the field data. This is just like a SQL statement, right? From fields, fields being the table, right? Order by row, order by our ID. Make sense? Here we go. Var statement. Now, if you ever did a statement, the difference is what we do is we wrap the statement. We prepare a statement, but we're wrapping it around the query. And again, this is the same for PHP. It's the same for any other thing that accesses some kind of SQL. Some kind of SQL. Doesn't matter we're using ASP.NET with Microsoft SQL, MySQL, any SQL. It's the same. You got to prepare the statement, and what we do when we prepare is we format it in the right way for the SQL server to understand what's coming. Okay, that's what's happening here. We create an opaque pointer again, another pointer to the statement. The statement is an object right now, right? And now here's our prepare. Notice it says this ugly line, SQL 3 prepare v2. Again, what is this thing? It's this darn n byte, right? Or opaque style pointer, which is of type it's a Objective-C thing. So what we're saying here is we're saying, okay, well, prepare this statement. Here's the database we have to connect to. Here's the query we just made. Some options, -1. And then here, this statement is a reference to the statement itself, right? Which is going to be storing or wrapping the query. If, and you could have put this in so many different ways. Why they wrapped it like this is the right way. I don't know. If it's equal to SQLite row, right? If this statement is equal to SQLite row, then do all this stuff. What are we doing? We're saying our row is cast as an integer. So we're taking the SQLite column int of statement 0. What's statement 0? The row. And our statement, which is right here, right? Our row is the first interpolated value of our statement. And statement 1, our field data is that part. So we're saying field data is equal to row data, and this is equal to our row to row, field data to field data to row data. And that's how we're getting the information from the database here and storing it inside of our row and row data. Okay. So we're selecting it. Now, if nothing exists here, we're going to get nothing. We're going to get 0. So this all it does is create the data, create a table if it doesn't exist. Here, what we're doing is we're actually polling the table for data. And if it doesn't have any data, we're not going to even do this, right? because it says while SQLite 3-step statement, right, is equal to SQLite row. So if there's something to get, like we have data inside the table, we're going to read this over and over again for each row in the table, right? But there isn't any row. There's no rows or data in the table initially. Okay. Here's our field value, right? Which is we're saying, okay, convert it to string. Our row data, we're actually taking the data here and then converting it to string. We're initializing it as a string and storing it in something called field value. And then from field value, we're taking it and storing it back in our line fields row, right? Row, which is the index, which is the ID of the row. So row 1, going back to this line fields idea. Line fields are relating back to my storyboard, which is this is line field 1. This would be index 0, right? Line fields row 0. The text value is this field value that we just read in for the database. That's what happens. Okay. And so maybe SQLite is easier for you. Some people find this way more difficult, right? That's why I prefer, I've given you both, right, to look at. Core data you can forget about. Seriously, it's way harder, in my opinion. But if you'd like to, the data's there, the things works, and it works just fine. All three work just perfectly. Notice this is exactly the same. The observer that we did before with application will resign active, right? Here's application will resign active, and here's our data file path. Very similar to what we did before. Wait a minute. How come we have a data plist here, right, with application will resign active? Why do we need a data plist? Well, let's take a look inside of our document. This is interesting what they did here, right, which I kind of liked, right? So let's take a look at this. So if I go to my Finder, and I want to go to that device set plist again for a second, just to get an idea of where to look, right? So if we go to Text Wrangler, remember this is our iPhone 6.2, right? So, or 10.2, here it is. All right, so here's our iPhone 6, which 55DA, that's the one. So I know that's the one I'm going to look at, which is our first one on the list. This is it. Cool, cool. We found our data plist. And before we ended up finding our other one, our single core data, we want to find the one that is for the one that we're using right now, which is this one here. Data plist. Let's take a look at this one. By the way, under library, you're going to see what this thing is, which is persistence with SQLite, right? Let's take a look what this data plist looks like. What is it storing? What do we need it? This. Remember we talked about SQLite being a pseudo database. It doesn't really have a server going on in the back end. We still use a property list to store everything, right? It's just encrypted. And that's why it's better than using a regular plist, because it's been encoded, right? So can you read anything here? Wait. just the query statement, just the table fields create, right? And that's it. Oh, what's this? Some stuff there that I put in, some names, right? So not quite secure as you'd like, huh? But that's where you see that's where the data is being stored. So even though we're not really using local data, we're still using some kind of way of connecting. And this is why, like I said, it becomes quite challenging. Okay, let's go back up here. So up to here, we're good, right? But when we get to here, this basically says, hey, do it the other way around. Make sure you read from the actual object itself, the lines in your rows, and then write them back out to the database. So here's where we do insert or replace. So application will resign active on both sides, both on the regular persistence model as well as on the SQLite model. What it does for you is it looks at this, the database, makes a connection again, right? If you have a problem, it'll shut it down. It says failed to connect, right? And then, and I don't like the fact that she used I. I'm not a big person, just any kind of other thing other than I and X and Y. It's just my style, right? I'm looping through each of the line fields here, right? Now, in this case, right, the line fields represent, again, the lines in our storyboard, right? 1, 2, 3, 4 line fields. So you're going to loop through 4 times, right? Okay. Loop through the line fields, and it's going to be, if you kind of click on this thing, right? So there's one open brace. Here's another open brace, right? Here's another open brace. So just to show, sometimes I want to do this. I want to say here, this is an if statement for SQLite step, because sometimes it's hard to know which brace closes what. And then I'm just going to show you this methodology. I do this all the time. So again, this one here, this closes this brace. So end if SQLite 3 prepare. This is closed here, right? We still got this one though, right? And what's this one? Is that the one? Right? This is our N4 loop. So this, all this, and you notice it's in the same line. If you guys are confused, are all of this stuff. So it loops through all of this for each of the line fields. So what does it do? Let update, insert, or replace into fields, which is the table name, the row and the field data that we're going to get. And notice that they have these two question marks. These two question marks are the way we can bind stuff up. We need to use something called SQLite 3 bind to do that. And there's different types. There's bind int in this case and bind text. And just like we did before, we're going to interpolate into our statement, right? Remember, the statement is a wrapper for our query. Here's our query, right? And we're going to interpolate and put this one here and this one here, right, into the values. And these values are the things that are going to insert into the database. Okay, that's how it works. But we need to use the SQL binding syntax in order for us to do that. Okay. Once we've done this, we've inserted stuff. And then here, what we're going to say is if my statement is not done, have an error. Otherwise, we're done. So finalize my statement, which means, and close down the database. All right. So all these lines here are required. And that's why you need both pieces. You need application will resign active, the data file path where we're going to store our temporary database, right? As well as all the code in our our view did load, right? All this stuff to simply store a few pieces of data, right? And that's why I find sometimes that maybe some people, by the way, this is empty. Some people find this even harder. Not only that, but on top of that, for SQLite, we have setup involved. You cannot use SQLite unless you connect to it. Notice that I have something here. Because I'm using Objective-C, I need to have something called a SQLite persistence. This is the name of the project, bridging header, right? If I don't have this bridging header in here, notice it says SQLite 3.h, and we talked about that earlier today, right? The H means the header. We cannot do SQLite. So we need to have this header in place right here. Okay, that's number one. 2, up here. Notice that also our linked frameworks must include libs SQLite 3.tbd, right? It must have that unlinked frameworks. That's another requirement. So whenever we create SQLite, we need to go into our manifest, go down to linked frameworks and libraries. And when we click this, it actually gives us, if I search for SQLite, right? It gives us 2 different types, right? Notice that there is 3.0 and 3. We want to choose 3, this one, okay? There's different, slightly different ones, all right? So please choose this one, okay? Not this one. Okay, this is the one for this example anyway. Once we've done that and we say it's required, it will link this framework and library to our application so we can do SQLite. So you need this piece and you need this piece in place. If you don't have those two pieces, ladies and gentlemen, you will never be able to do SQLite. That's what makes it a little bit more complex, right? And where I say, damn it, why can't they make it just much simpler than this? One click and you got the library that you need, right? This is Apple. Isn't this supposed to be the UI, UX, masters of the universe, right? But unfortunately, this part is still a little antiquated. It still needs updating, and they're going to work on it. We got to be positive about it. At least I am. Take a look. So I've got now one thing I don't need, if you notice, I don't need that extra library, right? That 4 lines library that they had in the other one, we don't need it here. All we need to do is integrate our SQL data right here. Now, if you're familiar with SQLite, this is definitely the way to go. However, if you're not familiar with SQLite, I highly recommend doing it with the other way because it's much more straightforward, right? Me, if I was going to choose which way I would go, I'd go this way. And that's why I recommended it. That's what I kind of giving you these two options, right? This is much more, this speaks to me when it comes to how I would do things. I don't need an extra class. I need a little bit of setup, but then this makes sense. This makes sense, a lot of sense, right? I wouldn't call it fields, the table. I might call it something else, right? But, you can make it, make it so maybe this would be the to-do lists or to-dos. That's what it would be called instead of fields. And instead of row, it would be ID, to-do ID. That's what I would put here. And instead of, it'd still be primary key, and it would be auto-incrementing and all that kind of stuff, right? And instead of my field data, right, which would be of type text, I would make my field data my to-do, right? So all the exact same things. So I can store multiple things instead of storing one file. The other way to make the other one easier, right, the plist way of doing things, right, I just got to say, this is the other way of doing it, is to use multiple files to write things into. So one for each of the things you're storing, right, which might make it easier for you. However, I think that's a much more complex solution. Easier to read and understand, much more difficult to utilize. Questions around SQLite. It's not that difficult. If you look at it carefully and if you read it, the code itself, the way I've explained it, it's actually a lot simpler, right? It just is a lot of code. There's a lot of code involved, and you need to know what you're doing. Notice that you still need to do this over and over again. What I would do is take this code, modify it, and adapt it to your use. And that's why I put these 3 different applications up on GitHub. So you have access to all this code really readily, so you can use it and test it and try it. And by the way, there's a problem. You can always go on Stack Overflow or Google, and it'll fix you for it. It's really that easy. It's not that difficult at all. All right. Here's one thing I would do if I was going to do it. Instead of storing all these different pieces of data for our application, store one. Try that one first. So don't store the is it done or not? Is it completed? Just store that one task. Can you store the task first? Yes. Great. Now do another little test where you can store more than one thing, right? And then try and figure that out. I want to end off this one with a little bit of a preview of what core data looks like so you can understand the complexity. And this is why I'm not doing it. So this is SQLite gone. Let's take a look at core data. All source. No, that's the one I want. I want to get the right one. Sorry, I just want to access the right one for you guys, so that way you're good, right? All right. All right. Let's take a look at this insanity. 1. Notice that I need this persistent XC data model ID. I need this right away. That's one thing I need. The good thing is when you create this model ID, one thing I like about core data is it's very organized. Notice on the right, you describe the type of data, right? My integer 16, so again, right, which is the line number, and then my line text, which is of type string. This is nice, right? But very different from Android, right? So if you're doing this, there's no equivalent, there's no analog in Android whatsoever, right? You'd have to use SQLite for Android and core data for iOS. There is no similarity, right? One good thing is our view controller is straightforward again, right? So if I look at what I've got here in my view controller, I've got a couple of things. I create key value pairs. Again, I'm using this collection line fields, very similar. Again, I'm looking, by the way, for people who are watching or who are looking at this here in class, I'm looking at the core data persistence, which is the third project in our class today. I'm just not going to go through it on the PowerPoint because, again, I'm going to tell you that it's a lot more difficult. Here, what we're doing is we're defining the line number, the line text as different private static objects. What does this mean? Why am I making it private static? What would be the advantage of doing that, first of all? Does anyone have a clue? By the way, you also notice I have to import core data. So I've got to import core data. I got to have that extra file. Those are two things I need so far. All right, configuration. There's configuration involved with this stuff. Okay, now I'm talking about an app delegate. Okay, my app delegate is my UI application.shared delegate as my app delegate. Whoa, that means that in my app delegate, there's got to be some extra stuff. Yeah, like maybe down here where we're lazy loading a persistent store coordinator. Yeah, this is what I'm talking about. You're not just dealing with one type of file. We're not talking about just a view controller anymore. We're talking about a bunch of additional things. We're creating a dictionary, right, for both the description key and the error key. As you can see, there's lots of information here, and this is nice, right? I'm just putting it out there to you. You're using an app delegate. Okay. Let request be my NS. Oh, God. Here we go again, right? Hey, I'm just putting it out, right? So you know what it means. I'm doing it really like, I'm exaggerating here. But I want you to see every time you see NS, you're thinking to yourself, Objective-C wrapper. I'm connecting to Objective-C, right? And I'm fetching my request results. Remember, we talked about this as my request. We're using something else now. We're using an object relational model, which is what it's doing is an ORM is a wrapper around SQL. That's what it's doing. So actually, it's creating a same kind of database. Core data is just a database, right? My entity name is my view controller line entity name, right? You can call this whatever you want. They didn't have to do this. They could have called this line model, right? Same thing, right? You're putting it all in a do catch, try catch. Notice the number of lines here. It's doing the exact same thing as we did with our SQLite, okay? Just not make this bigger so you guys can see it. It's kind of hard because there's a lot of lines of code here. Well, basically what we're saying is this. We're defining line number, line text, and text field, right? We're making a reference to the text field as one of the line fields based on the line numbers, the number of line numbers there are, right? So we're reading how many line numbers there are, and we're making a reference. This text field is representative of the line numbers. And here what we're doing is we're reading the value from the data store into our line number and our line text, right? And we're taking the line text itself, we're using the line number as a reference and an index, and so the row index as what's happening here, and we're assigning the line text that we're getting from the object into our text field.text object. Text field being our line fields, whatever it is. Line fields being our IB outlet collection that we connect all of our text field to, just like we did last time, each one of them. Cool. Oh boy, here's our observer again. Wow, do you see the thing that's happening in every single one? Application will resign active, right? What is this doing? It's going back here, and we're going to write to it. So one is the read we just did. It's exactly the same thing, but in this particular case, we're going to write to it, right? Now we're using, again, this shared delegate, right? We're using a delegate. Whenever you think about delegates, to me, what's a good analog? An anonymous inner class. There we go. That's a delegate. If you guys know Java, then you're golden, right? It's an anonymous inner class, right? An anonymous class, right? That's what we're doing with a delegate. And we're saying that this shared delegate, this anonymous class, right? We're casting it as a delegate, and we're assigning this app delegate, right? And we're going this. We're saying, well, let's make this anonymous class app delegate.manage object context. And for every line field now, we're going to read from the line fields in this case and assign the data to our text field, right? And now we're making a new request. The first request up here, right? This is core data, right? Was a fetch request, right? Where we did a fetch from the data store. And here we're also doing a fetch request. What we're doing is we're connecting our line entity, right? We're connecting to our data store, right? Now, predicate. This is interesting. The predicate itself is the way for us to connect our line number key to the actual data that we're getting. And then in our do catch, right, we're writing things out. That's what's happening. So our objects, we're going to try and fetch the context from the requests. And then where the line is the manage object, like you can see how challenging this is to read, right? Because we're using an object relational mapper, it's supposed to make it easier. And where everything happens is these last two lines right here. All this stuff is set up. We're setting, we're connecting, we're setting, and we're connecting, and now we're writing, finally, on these two lines. These lines 71 and 72, all the magic happens on these two lines, right? Or we write back to the data store. That's it. So to me, you need to do a little bit of studying to figure out this out, right? It's a little cleaner when you figure it out, to be honest with you. It is. And it's way more secure. Notice that there is no plist object, which is what we want. We don't want a way of somehow reading this information. But wait a minute. Isn't there? No. Right? plist, single view core data. Can I read this stuff? Is there a way of picking it up? If I right click and I go open with, oh man, text wrangler, can it show me anything? Except for these upside down question marks, right? Hell no. It's all encrypted, right? And that's why people decide, for the most part, to use something like core data, because core data, it's just, it's secure. It's a way, it's encrypted going out, it's encrypted going back in, using anonymous, our app delegates and observer patterns and everything else to connect and with everything that you need to. And to me, fantastic. But unless you read about it, and by the way, it's not difficult to try and figure out what's happening here, right? Like they called something the line, right? So, and again, this is her code, right? So let objects is, you're going to fetch the request. Here's what we're doing here. And then the line, which is of type NS managed object, you're casting it here. You're not, how we normally do, instead of doing explicit casting, this is explicit. We do inferred data type, right? We're using type inference. Here, we're not doing type inference. We're actually telling it. It's an NS managed object. Why? Because Swift would not be able to understand what this is, because it is Objective-C. So it doesn't understand what it is. It can't figure it out. So we're telling it what it is. And then we're saying the object's first object as a managed MS object, the MS managed object, which we're actually inserting the new object. Here's where the inserting happens into the data store, and we're writing out the data that's going to go into that object. Can I read it? Yeah. Would it be easy for you to interpret and use in your code? I don't think it's a reasonable thing for me to ask. That's my answer. Questions? How about this? Opinions. What do you think you're going to use for your assignment 2? Are you going to use plist? Very easy, string, kind of a single file. SQLite, I recommend. Or are you going to use core data? Anyone going to use core data? Anyone interested in using it? You want to use core data? It's a challenge. Okay, it's more secure. If you're going to do it, I will give you a bonus for it. It takes a little bit of research. Okay, SQLite. Who's going to use SQLite? I'm going to give you a bonus if you use SQLite. If you use the other one, the plist, it's possible. I'm telling you, it's not a big deal. Any one of these ways of doing things is okay. It takes you a little bit more adapting to make it work, but it's quite simple and straightforward. Like really it is. If you actually look at it might seem like it's not, but going back to the plist, and I'll end you guys with this one for today. And I'll give you guys a little bit of time at the end. We'll talk about stuff and look at your code. So I want to see what you got so far, right? If you're, I'd like to try and go around and do that. Let's take a look at that one for a second. So if I go File, Open again, and I want to look at this, the original persistence one. Like at first glance, the thing that I don't like about this is the fact that we're using 4lines.swift. That bugs me, right? The fact that I need to do encoding and decoding, copying and moving things around, right? And it's another little thing to add in, right, with the lines key and everything else. This is going to make your code a little bit more complex to adapt, right? Good thing is no app delegate. Notice this is the normal app delegate, what it looks like. I don't need all that extra code that core data requires, right? But this, I think the thing that makes this a lot easier for me to get, if I was going to choose this path, is you got a data file URL, right? Once you do this, and literally, I mean, if I was going to use it, I would just copy this exact function. I'm asking you to. Please don't try and rewrite this. Why would you? Take this data file URL and include it in your code if you're going to use it, right? Because this, what it will do is it'll create this thing called data plist. Don't call it data plist, call it something else. But at the end of the day, it'll create that for you in your application, right? Just by using this piece, okay? Application web design active. This is the smallest application web design active that we've seen so far in the three different types, right? And it's also the most understandable, to be honest, right? Why? Because here we use the 4 lines to do our, to create our array, right? And we're using our 4 lines as a container so that we can write out back to the, to the plist file. That's what we're doing here, okay? My bother is this, data being an NS mutable data object that we're writing back out. We're using data.write, right? That bugs me, right? And it bugs me because even though it makes sense and it's easy, because 4 lines, we're encoding. We're using the archiver to encode the 4 lines that we're getting. That's why it's called 4 lines. Notice why it's called 4 lines? Because 1, 2, 3, 4 lines. That's why they do that. So that's why it's called 4 lines, right? It's made specifically for this application, right? Because what 4 lines does is it creates each of the lines. It represents each line here. This object here represents each of the lines. Okay, and again, we have an encoder, and so this is our initializer, right? And we copy lines into the actual object. So this is what this is, and it's using again these 2 protocols. Again, complex but understandable and usable, right? Literally, you could use almost all of this and not have an issue. My challenge is, how do you adapt, instead of my lines being what it is, to how we have multiple text fields, or one of them is our to-do list, another one is a Boolean type, which you guys have to figure that out, right? How to keep track of what the Boolean is, whether it's completed or not, right? Because if you look at the document that I gave you, and I'll stop with this, I promise, I swear, no more talking, right? I'll go around and talk to you guys, right? But if you look at the document, right, that I've given you for your assignment, which was a couple weeks ago, I've asked you for 3 different objects, right? By the way, I only did 2 with you the time we were together. I did my name and completed, right? Those 2 things. I started building your UI, right? Notes is another thing. So there's actually 3 objects plus your ID. Again, to me, this maps much better to SQLite, me, right? For you, if it speaks to you, he doesn't have to. You can store as much data as you want. And if you actually research the plist way of archiving data, there's tons of examples online on how to do it, right? Truly. The best way I would start would be to look at the code we have already and to do something like this. Use plist to store data. iOS. We have to also signify that with the Swift 3, right? And there's tons of, look, this is made, last year in May, and there's a whole step-by-step on how to do that. Here's my new route. It talks about the key, the type, and then the data. And this is your plist edited. And then you can see that how to set things up, how the core data is unchecked, and how to follow through and to create your application, right? And there's a bunch of items that they put together. And it talks about all kinds of ways. And what I'm going to do for you guys, I'm going to copy this, I'm going to put it up on Slack, so you have this as an alternate. Okay? So I'm going to say something like this. I'll say walkthrough for plist storage option. There's one right there. Okay, so take a look at that. That might help you out. Now this says Swift 2.2, so be careful about that. So you may have to convert some of the code that it gives you, but it still will work. Swift 2.2 is closer to us than Objective-C, that's for sure, right? So you can see that some of the stuff here, how they talk about how everything is written and how to write it, and this gives us kind of an idea of where they store the data and how to do stuff. So this is good, like a good step-by-step. And same thing, if I was going to say instead of use plist, if I said use SQLite 3 to store data with iOS and Swift 3. Here's one from Ray Wenderlich, right? He's got some really good tutorials. This was done from March 3rd, again, probably with Swift 2.2, my guess. But this one here would probably be a really cool walkthrough, and maybe even sometimes he has videos too. No. So Xcode 7.3 in iOS 9 and Swift 2.2. Again, this is the date, and sometimes what he does is he bounces you to other things. A very good site, where they have all kinds of information, and they give you examples very similar to what we've seen in our code, right? And you can see what he's doing here, right, by creating a table and explaining how this all works, right? So another little walkthrough, which I'll take, and I'll put this, and again, Ray Wenderlich is a very popular site, right, and it talks about everything in here. So again, I would say walkthrough for SQLite storage option. A good one. And I think it's pretty good. I think he went really in a lot of detail. He does things differently than we did, that's for sure, right? But he also has at the end one things that they do here on their site. If you scroll all the way down, and this guy who did it was Chris Wagner, right? A lot of times you can download the complete tutorial right here. So this is the project, and you can convert it first, take a look at the code, and go from there. And that's what I like about what they do. Let's do one more, and then we'll stop, which is use core data. There we go, right from the same guy, right? Or same group of people, right? And we can see this is October 6th, so later on, which means chances are it'll be Swift 3, right? And you can see that he's using Xcode 8, which is a good sign, and master detail application to do some stuff with us. So he's talking about how to do these things. So if you're looking at doing core data, this is a really cool tutorial, it looks like. That probably will get you through things and step by step a lot cleaner than some of the stuff that we saw in the book. You can see that there's a bunch of stuff here, right? So this is another thing you might want to look at if you're modeling your data out, right? And it talks about how to connect and all the difficulties. It's quite an involved one. I'm going to take this one here too. So again, this would be walkthrough for core data storage option. Questions around this stuff? Guys, that's it for me today. I'm not going to kill you. I'm already killed. I don't know about you. But I want to, before you take off, I want to, for the people, I'm just going to go into the rows. And if you've got something to show me, I'll see it. If you don't have anything to show me, it's okay. You can go, right? But I want to take a look and see what you've got for assignment 2. I know I kind of asked you for your UI. If you have nothing more than just your UI from last time, it's okay. I have that already. But if you have something else, if you actually have some progress, I'd like to see that, okay? Thank you so much, and we'll see you next week. Remember, for your exam, please be on time. We're not going to include data. It'll be an option, right? If you do data, and you'll get bonus points for it.